Hello, dear students. I am Samir Velankar. I welcome all of you to this another video on linked list data structure. In this video, we will see how to convert a singly linked list in reverse order. Now, suppose we have a singly linked list as shown in the diagram. 10 is the first node, so first pointer is pointing to 10, and 10's next is pointing to 20, and so on. And 40 is the last node, so next pointer of 40 is null. Now what we want to do is that we want to reverse this list. What does it mean is that we will have node 10, but notice next of 10 was pointing to 20, but now 20 is next. Next pointer of 20 will point to 10. That's what I call by reverse. And 20's next was pointing to 30, but now 30's next will point to 20, and 30's next was pointing to 40, but now 40's next will point to 30. Also, the first pointer, which was pointing at 10, will now point at 40. So last node 40 will become the first node. And most importantly, 10's next will be null, indicating that 10 will be now the last node. So that's how we are going to convert the linked list in the reverse order. Now, first solution to this is a non-recursive solution. Although on the left-hand side, I have written a recursive solution, which I always claim to be better than non-recursive one. But what will be the non-recursive solution is we can declare an array. So we will require an additional space in the memory. We will require array. Array will have some fixed size. Obviously, array always has fixed size. And what we will do is that the source linked list given, which was 10, 20, 30, 40, will be traversed using our usual method. From 10 to 20, we will traverse this list and copy all the values in the list 10, 20, 30, 40. We'll copy all the values which are stored in the list sequentially in the array, let's say A. And now, once we have copied all the values from first to last, 10 to 40, we will traverse this array backwards. Okay. And now we will take the last element first, that is 40, and we'll create a new node, store 40, and this will be claimed. 40 will be made the first node. Then as we go backwards in this traverse, 30 will be the previous one, or rather the next value that we will take. So we'll create a new node for 30 and ask 40 is next. 40 is next to point to 30. Similarly, as we take 20 backwards, 30 is next will point to new node 20, and finally 10 will be added, where 10's next will be made null. So this is the reverse of the given list 10 to 40. We have got 40 to 10. Although this solution is acceptable, this is non-recursive solution, but then the problem with this solution is we are using too much of space, additional space we are using. Just check that we have to declare an additional array which can copy the values, and then that values are taken backwards to create the linked list. What if the linked list was too large? Let's say it contains 10,000 nodes. Then we will have to declare array of size 10,000. So the space used by my program is immense. So although this solution is acceptable, we will go for the recursive solution. And you watch, the recursive solution written on the left hand side is smaller in size. That's also an advantage, we can say always. So let's see the recursive solution. All right. Now in the recursive solution, I have written one function called reverse, void reverse, which has a parameter pointer p, node pointer p. Now this pointer will be initially equal to first pointer of the list. That is, reverse function will be called from main as reverse first. We will be passing first pointer to this reverse function. So the pointer p, the parameter p, will be initially equal to first. So let's show reverse function running with parameter p and P is storing address of 10 because P is equal to first initially. So P is at 10. The pointer P is at 10. I hope you understand. So the first function has begun with reverse function having a parameter pointer P, and P is pointing to 10. Now, when you run this function, there is a if statement which is asking is P arrow next not null. Now observe the cursor place P arrow next, P arrow next. This next we are talking about, isn't it? P arrow next. Is it not null? Yeah, it's very true because P arrow next is pointing to 20. In fact, the next of 10 is storing address of 20. So this condition is true. You can say in English or just a natural language that wherever P is pointing, the next pointer of that node is not null, and next pointer of the 10 is pointing to 20. So the if is true. So we will be executing all the statements written in the if, but observe the very first statement written in the if is called to reverse again. This is a recursive call, isn't it? Reverse is calling reverse. But the parameter passed is P arrow next. Literally P arrow next means address of 20. Observe P arrow next, that means next of 10. Next of 10 is nothing but address of 20. So the reverse function is called by passing address of 20, and that address of 20 the parameter P again of the function. So the fresh function starts due to recursive call, and the function is reverse with parameter P. P is the parameter and P is now pointing at 20. So there is a pointer P, the parameter P, which is now pointing at 20. You all know that the pointer P at 10 is also existing and pointer P at 20 also exists. Yes, there are two copies of P, but one of the P is local to function which was running for node 10, and the other P is local to the function which was running for 20. So you all know that every function maintains the local parameter. The local parameter will be alive till the function is running. So we have got two copies of P, but currently active is reverse P because the function running is reverse P with P at 20. Okay, let's run the fresh function reverse with pointer P pointing at 20. We will check if P arrow next not null, which is very much true because P arrow next means 20 is next, 20 is next is 30, it is not null. So in the if statement, reverse is called again, recursive call, and we are throwing address of P arrow next. Now what is P arrow next? P arrow next, check the cursor place. P arrow next means 20 is next, and 20 is next is storing address of 30, isn't it? Next pointer stores address of 30. So reverse function is called recursively with parameter P again existing and P pointing at 30 now. So the fresh function has begun with the parameter P pointing at 30. Let's start this function. Reverse P with P at 30. If the function starts, it will again check is P arrow next not null. We are asking is 30 is next not null, isn't it? Well, observe 30 is next is storing address of 40. So it is not null. Hence, we will enter the if and call reverse again with P arrow next. But P arrow next now is 30 is next, which is storing address of 40. Hence, reverse is called with parameter P with P at 40. So fresh function has begun. Pointer P now pointing at 40. So we can say now reverse is running for node 40 because P is pointing at 40. When this function starts, the if checked will become false. This if is false because P arrow next not equal to null is false. Check what is next. P arrow, check the cursor place. P arrow next is null. You observe 40 is next is null. This indicates that we have reached the last node. The function reverse is running for the last node because next of that node is null. So as the if is false, this if is false, P arrow next not equal to null, we will go to else. And the statement first equal to P will run. Now this is nothing but pointer becomes equal to pointer. A layman will read this line as first should point to the same node where P is pointing. So first will discontinue to point where it was pointing. Am I right? First will discontinue to point where it was pointing. First was pointing to 10, isn't it? But now we are asking first to point to the node where P is pointing, first equal to P. So what we have is first will now point wherever P points. That means first is going to point to 40. I guess you are understanding. So how 40 has become the first node due to the line first equal to P. Okay, now what? Now the next line runs obviously after first equal to P and function comes to an end, you watch. But which function is coming to an end? The function obviously which is executing, and the function which is executing is reverse P with P at 40. Look, I am striking out the function. Reverse 40 has come to an end because it has finished all its lines. It has executed else, and after else there is sheer end of function. So you know whenever a function ends, the calling function resumes. So here we are back to the function reverse P with P at 30. It seems that we were running 40, but 40 has finished, so we are back to 30. But you all know that some garbage is deleted now. The P, the pointer P, which was created for that node 40, will be deleted. Stick to fundamentals. And we are back. We are back in the function reverse 30. Let's see now what happens when we are back to reverse 30, P at 30. What resumes in reverse 30 is P arrow next equal to P. I hope you are understanding. Reverse 30 will say that last time I was at the recursive call, I did this recursive call, reverse 30 will say. So reverse 30 says that I will resume from the next line from where I had left out last time so that I can complete my statements. So reverse 30 will resume with this line P arrow next equal to P. Very interesting statement. You just watch. P arrow next, check the cursor place. P arrow next, that means we are talking about next of 30. But P arrow next has been written. This is arrow next. That means it is next of 40, isn't it? P arrow next means next of 30 and next of that node. So that is next of 40 should become equal to P has been written. Is equal to P has been written. So P arrow next, 40 is next, is going to point wherever P is pointing, but note that P is pointing at 30. So what it means is that the next pointer of 40 was null, but it will be no more null. Are you understanding? And next pointer of 40 is now pointing wherever P is pointing, and P is pointing to 30. Great. This is really well, very interesting. P arrow next, that is 40 is next, will point wherever P points, but P is pointing to 30. Great. Now the next line in the function P arrow next equal to null. Observe the next line. What is P arrow next here? P arrow next is 30 is next because we are in this function. So P arrow next will become null. What it means is P arrow next was pointing at 40. It will not point at 40 now. It will not point at 40, but P arrow next, that is 30's next, will become null. You can see that we have broken the association between 30 and 40, but now association is between 40 and 30, isn't it? So 30's next, P arrow next has become null. After P arrow next becomes null, there is end of if. And you know else won't run because if was true. So after the if ends, there is nothing pending but the function ends. I hope you are understanding. So the function reverse P with P at 30 has come to an end. This function which was running for the node 30 is ended. What it means is it is going to destroy the local parameter P which was made for this function. So the function function which was running for node 30 has come to an end. So what are we now? We are back to the calling function. Calling function was reverse p with p at 20. We are back to this 20. And obviously the function for 20 will resume with the line p arrow next equal to p, because it had finished the recursive call last time. So if you trace the line p arrow next equal to p, p, just check the mouse place or the cursor place, p arrow next, this next, arrow next again. So next of 30 is now going to point wherever p points, but p points at 20. So next of 30 points to 20. That means next of 30 is no more null. We short while back we made it null, isn't it? To break the association between 30 and 40. But now next of 30 is no more null. Next of 30 is pointing at 20. Now continue with the next line. P arrow next equal to null. Observe the mouse place, cursor place. P arrow next equal to null means 20's next should become null. So 20's next, which was pointing at 30, will no more point at 30. Correct? And 20's next will be null. So what we are doing is we are breaking the association between 20 and 30. But 30 and 20 are now associated. 30 will be pointing to 20 and 20's next is null. Well, after p arrow next becomes null, the if ends and obviously the function ends. So I am destroying this function comes to an end. P at 20 comes to an end and we are back to the function reverse 10. Very interesting, isn't it? Very interesting. Reversal of a linked list, singly linked list. So now, when we are back at reverse 10, where p is at 10, it will resume from the line p arrow next equal to p. You very well understand p arrow next is next of 20. And next of 20 is now pointing at 10, where p is pointing. And then last line in the if is p arrow next equal to null. Check that p arrow next means 10's next, isn't it? And now 10's next is going to become null. I hope you have got this. 10's next has become null. So we have broken the association from 10 to 20, but we have an association from 20 to 10. After p arrow next becomes null, the if ends, so the function ends. So reverse p with p at 10 is getting finished, isn't it? Obviously, the parameter p is going to be destroyed. And we will be back in main, because who called reverse 10? Reverse 10 was called from main. So main will resume and look, we are having a reversed list with 40 as the first. And next of 40 pointing to 30, next of 30 pointing to 20, next of 20 pointing to 10, and next of 10 is null. Great, isn't it? I hope you have understood how to reverse a singly linked list. Thank you very much.